Okay, well, hello everybody. Come on in, grab a virtual seat. Welcome to another presentation of the online ColdFusion Meetup. I'm Charlie Earhart, and I'll be your host for the next hour or so. In this edition of the Meetup, our 293rd on Thursday, November 11, 2021 at noon U.S. Eastern Time, we've got Brian Reilly, who's going to give us a talk on avoiding server-side request forgery vulnerabilities in ColdFusion, CFML. Thanks for coming on, Brian. And with that, you go ahead and take it away.
Sounds good. Thanks, Charlie.
You bet.
Okay, well, good morning, good afternoon, good evening to everyone here. This is a talk that I've been very excited about, so I'm really happy to be presenting to folks today. For today, we are going to talk about two topics. We're going to talk about server-side request forgery, and we're going to talk about ColdFusion. And so this should hopefully be a pretty accessible talk. Even if you're not familiar with server-side request forgery, even if it's not a vulnerability that you've either seen before or don't know too much about, we're definitely going to break it down to the basics. It should be pretty understandable. And honestly, even if you're not super familiar with ColdFusion, we should hopefully be breaking that down into small enough pieces where hopefully by the end of this, you'll understand what server-side request forgery is, how the attacks could work, why they're important, why they're things that you're going to want to fix in your code, and then how you can actually do that within ColdFusion. Just one quick piece of tech housekeeping as we get started. I'm running with one monitor, so I can see my slides, and I can't actively manage the chat. I will try and do my best with that, but ideally Q&A at the end, and I am happy to answer any and all questions. And also want to say from the outset, my ideal audience for this talk is ColdFusion developers and security builders. So for the folks who might be on the offensive side of security, so pen testers and application testers, a lot of this really isn't going to be ColdFusion specific. They're already going out and testing for server-side request forgery. They're already able to find these vulnerabilities. My real interest here is that there's lots of great ColdFusion security information out there already. This is a topic that I haven't seen covered. So my thought is that this may be a blind spot. This may be a vulnerability class that either isn't fully understood, may not be on folks' radar. So certainly if you were building ColdFusion applications, or if you're a security person working with developers, building security tooling, helping them detect bugs, find bugs, this is hopefully helpful content. With that said, today is going to be a pretty narrow topic. So if it isn't ColdFusion and if it isn't server-side request forgery, we're probably not going to cover it. Again, happy to kind of answer questions in the Q&A, but just to kind of set at the outset some things that are out of scope for today and not on the agenda. You may have heard of another vulnerability class called cross-site request forgery. Similar sounding name, but completely different vulnerability in terms of how it works, how it may find its way into your applications, how attackers may take advantage of it, and what you would need to do to fix it. So again, today is just all going to be server-side request forgery. We're also going to cover why server-side request forgery is bad and why you should care about it, but we're not going to go super in depth into how an attacker might use it to carry out an end-to-end attack. So we're going to find some examples of how it works and how someone might exploit it. But again, going really in depth into how you would fully maybe extract data or run commands or combine server-side request forgery with other misconfigurations or other vulnerabilities is kind of art and science, and is going to depend on a lot of factors. Again, I can certainly answer questions about that. I can point folks to resources on the topic, but today we're only going to be able to go so deep. And then also using the graphic here, today really is going to be one grain of rice on the overall heap of web application security. If you're building applications, there's going to be a lot more topics that you're going to be concerned about. There's going to be other things that you need to do from secure coding, secure design, and security testing point of view. Again, lots of great content online about that. So if it isn't server-side request forgery, we're not going to cover it today. But again, happy to answer questions about that in the Q&A as well. Okay. Before we dive in, a little bit about me. I'm a security guy for about the past 13 or so years. My main focus has been on application security. So working with development teams to test products, working with web applications, mobile applications, general software, looking for vulnerabilities, building secure software. Before that, lots of other security experience, ranging from incident response to security operations, to security policy and other areas. I've been fortunate to work in several different verticals. Early on in my career, I spent a long time in higher education. So if you're currently doing ColdFusion in higher education, I've been there. I can feel your pain. After that, I spent some time supporting state and local governments, and then more recently, a lot of time working with financial services and various tech companies, software companies, both small and large. I'll also say from the get-go here, I am not a ColdFusion expert. I am 100% convinced that there is much deeper ColdFusion expertise out in the audience today. But at the same time, I've had exposure to ColdFusion for a long time. I was trying to pin down the exact date and exact year. I think it was around 1997. And so again, most of my experience has been with trying to secure applications, trying to build secure applications, working with developers, working to protect ColdFusion environments. And this has really kind of run the gamut from things like small user-developed applications, internal applications, commercial products, as well as third-party software. Okay, so let's dive right in. Server-side request forgery, if you're not familiar with it, is a software vulnerability where an attacker is able to make web requests from the application environment. So they're able to make web requests from the server. And we're going to walk through some examples. So if this isn't clear from the outset, hopefully it should be soon. Normally, it's going to happen when an application consumes a URL from user input or consumes some other information from user input and then uses that to create a URL that's then passed in a server-side request. There's a bunch of reasons why you should care about this, how it could impact your application environments. When attackers go and are able to exploit this, they may be able to do a number of bad things, such as connect back to the server, so connect back to localhost in a way that they wouldn't be able to do externally without server-side request forgery. They may be able to connect to internal hosts, or they may be able to connect to trusted hosts that the application server can connect to, but they can't connect to directly. A lot of times, these attacks can lead to leaking sensitive information, things like API keys, credentials, or other things that you certainly wouldn't want to get out. A lot of these attacks do have to do with web requests, but you can oftentimes set them up so that you can make requests using other protocols. So it doesn't always have to just be web. And then also, in combination with other vulnerabilities or in combination with other environment factors, these can, in some cases, lead to command execution, which would be a super serious vulnerability. Also, when we're looking at server-side request forgery, there's two main types. Honestly, from the developer's point of view, these really aren't that important because you're going to want to find and fix all of these. These differences really only apply to cases when, let's say, you're a security tester and you're actually trying to extract data, or if you were a real bad guy trying to do this stuff. But when we look at the types, there can be fully informed server-side request forgery. And this is when the application is going to display the response from the server-side request forgery attack or request. And then the flip side of that is that blind server-side request forgery is when the application isn't going to display that information back. So the attacker can see, yes, the request is being made. Yes, I'm able to control where the server goes, but the application may not display the full response back to them. To kind of use a comparison, if you're familiar with SQL injection, you may be familiar with informed SQL injection, where you're going to get verbose error messages back. You're going to see the responses from an injected query. Whereas with blind SQL injection, you can infer that SQL is running. There's things you can do to tune and tweak it, but you're not going to see that full data. But honestly, even from the attacker's point of view, oftentimes you can still do lots of bad things with server-side request forgery. Sometimes you can turn blind into informed. Sometimes it really doesn't matter that you can't see the full response. You can still instrument an attack to do what you need it to do. You can kind of infer information about the target environment or the target application, where honestly, fully informed or blind are both going to be bad vulnerabilities that you're certainly going to want to find and fix. Okay. Also, even more timely now, folks may be familiar with the OAuth top 10, but if you're not, this is a consensus document made from input with security folks and developers, where they're going to list out the top 10 web vulnerability classes. And so if it's important to you that you're testing your applications against the OAuth top 10, recently in 2021, the updated list came out. This came out, I think, about a month ago. And as we can see, server-side request forgery squeaked in there as number 10 on the list. So if you have a requirement, if you have a need to do OAuth top 10 testing, certainly understanding server-side request forgery and making sure that your applications are secure against it are going to be important. Okay, so let's dive into a contrived example. And so I want you to think of a really, really basic web application. And this application has a text box where a user can enter in a URL, and it has a button. And when you click the button, the application is going to take that URL, request it server-side. So this is server-side code running. It's not running in client-side JavaScript. It's not Ajax. It's the request is being made from the server, and they're going to display that result back. So if we look at this sample code on the right, again, folks have known for a long time that tags like CFHTTP are dangerous. And I'm sure this looks nothing like code that people would ever deploy in production, let alone even in an internal environment or a test environment. But if we look at this, so we have a CFHTTP tag, and we are passing a URL parameter called URL that passes a URL. And so the user can control that. They can control what they're putting into the text box. And so this is going to be requested from the server. And when they click the button, no surprise, what's displayed back is the raw HTML of that request. And so in this example, we just hit Google, but certainly you could put in any URL, request it, the server would go and fetch it, and then it would be displayed back to you. So hopefully it's starting to come together about how this is a problem or how an attacker could take advantage of this. But let's walk through what a simple attack might look like. So we have our malicious hacker somewhere out on the internet, and we have our internet-facing web server that has a server-side request forgery vulnerability on it. So the attacker is going to send their request. They're going to send their attack with a server-side request payload. And let's say this is like the last example where that payload is just going to be a straight URL. So what could they do with this? Well, right off the bat, the attacker could say, you know what? I'm going to connect to random hosts on the internet. And so maybe I'm going to attack them and send attacks to those servers. Maybe I'm going to try and overwhelm them with traffic. Maybe I'm just going to see what's out there. And so those external internet targets are going to see those requests coming in from the application server. So it's going to look like that application server is hitting those internet hosts. And yeah, you can certainly trace this back, and there may be logs on the web server that's getting attacked that point back to the real attacker. But at least from a quick view, it's like the attacker is able to use that web application server as their own personal web browser. What else could the attacker do? Well, they could say, you know what? I'm going to see, can I poke around on the internal environment? So can I find internal services? Can I find internal servers? Can I find interesting things that I can't reach directly, but if I'm piggybacking through this application server, I can poke around. And so they can try various host names, they can try various IP addresses, they can try various ports, and they may find more vulnerabilities, they may find sensitive data, they may be able to reach things and pull things back that they wouldn't be able to do if that vulnerability didn't exist on that public web server. Also, let's assume that this web server is in a public cloud environment. Some of these attacks no longer work because they've since been secured, but all of the public cloud servers have metadata services. So these are internal APIs that you can hit from the cloud servers that will either perform some function, give you information about your target environment, so give you system information, give you network information. And so a lot of times, initially, these services didn't have much security, didn't really have much authentication. So if you were on a cloud server in a cloud environment, you could just make direct requests to these. So again, the assumption was, well, these are always going to be coming from trusted hosts and trusted environments. But server-side request forgery kind of turned that on its head. And for a long time, this was a popular way to weaponize server-side request forgery. And so again, I wouldn't be able to hit those metadata services in your environment on my own when I was remote. But if I am, again, passing my attack through your web server, I can go out and potentially hit things like that. Okay, so let's jump back to ColdFusion. A while back, I was reading some ColdFusion documentation, as one does. And one of the functions that jumped out at me was FileGetMimeType. So I was looking at the arguments that it took, and I saw that it can take either a path or a file object. And it was interesting because there was no distinction in terms of how the function would know what kind of object. So am I passing it a path or am I passing it a file object? And so you can see examples of this tag used in various pieces of software. You may be using it internally. If you look at some public projects, you may find uses as well. But let's use the code here on the right as an example. And so this could be part of something like maybe a file upload form where you're concerned or you're going to check the MIME type of the files that are being uploaded. This could be maybe part of a webhook or something that's retrieving files or checking files. And so in this example, the user is able to upload this file. So whatever they upload is going to be stored and passed in that form.file variable. And that's going to get passed as an argument to FileGetMimeType. And so I was wondering, well, so normally maybe it is expecting me to upload some chunk of binary data, so image data or something like that. But what would happen if you passed it a URL? And so there's lots of ways to test this. We could certainly take that little piece of code, put it on a server, and hit it directly. You can also use command box and use REPL to run functions directly. So right here, I'm running FileGetMimeType, and I'm passing it a URL just to my own local server where I can monitor the connections. And so I'm passing in a URL, and then as I monitor the traffic on my local server, I can see, yes, I am getting connections there. So a couple of heads, a couple of gets. And so this showed me that at least this specific tab, this specific function was vulnerable to server-side request forgery. So in the pass case, if you're passing user control data to this function, an attacker could carry out a server-side request forgery attack against it. And so once I found this one, I had a feeling there may be other vulnerable tags and other vulnerable functions. I wanted to find them all. And so this was a great example or a great opportunity to fuzz. And I wanted to fuzz and find all the things. So find all the vulnerable components. Initially, I had started to go through ColdFusion documentation and Lucid documentation and doing some automated processing to, again, find where all the functions that take things like URLs and file paths and things like that could be vulnerable to server-side request forgery. But as I kind of got deeper, it was a lot of pages, it was a lot of documentation, and I was concerned that I'd miss some. And then I was also worried about maybe the case of there could be tags where the arguments that they took weren't explicitly defined as files or paths. And if I just read the documentation, I could miss some more. So what I decided to do is I wrote automated test cases for all the ColdFusion tags and all the ColdFusion functions where I passed unique URLs into all of them, and then monitored all that traffic to see which ones actually did call back to the server that I was monitoring. So again, pass URLs in, watch to see what called back, because that was confirmation that if an attacker or if a user was ever able to control those arguments into those functions, those tags would be vulnerable to server-side request forgery. Certainly still possible that I could have missed some, but I'm pretty confident that I had pretty good coverage. I will also mention a couple of caveats here. Primarily when I was doing my testing and my fuzzing, I really was just looking at HTTP, HTTPS URLs. ColdFusion can support lots of other URL schemes, so things like FTP and file and tar. Those could also be ways that you could probably do things as well. But again, just for quick testing, mainly focused on web. Same thing goes with things like reading or writing to local file system paths or UNC paths. And then also, I didn't really dive in much into like raw network connections. So obviously there's tags like CFML and CFTP, where it's known that you can establish network connections. That's a little bit out of scope for server-side request forgery. And I think, again, a lot of those functions are known as cases that you need to be careful about, and probably wouldn't be cases where you would directly be passing user input. Okay, so now we're getting to the good stuff. And so we're going to go through the lists of the tags and functions that are actually vulnerable. Don't worry, you're not going to need to screenshot or pause. These tags are listed online. I have a companion blog post where I walk through most of this information too. That is short URLs as tinyurl.com/SSRF in CFML. So certainly after this, if you want to go and review those entire lists of tags and functions, we can do that. But so let's dive in. All right, so there were a handful of tags, and so all of these tags and some of them, as noted, are Lucy only and won't apply to Adobe ColdFusion either because of their non-existence in Adobe ColdFusion or how they work. These are the handful of tags where you're definitely going to want to take care, and if you're passing in user supplied input, you're going to want to validate that. We'll talk about that a bit more. And so if we look at the list of functions, we have a large list of functions too. So we have things like FileGetMimeType, which we looked at before, but again, lots of other functions here that if we do pass user input, you're certainly going to want to take the time to validate that input and understand how the functions work, how your application works, to make sure that that users and attackers aren't able to do anything malicious. Okay, so right now we have our list of vulnerable tags and we have our list of vulnerable functions. So you may be wondering, you know what, if this applies to me, how can I fix this situation? How can I avoid server-side request forgery in my applications? So right off the bat, you want to find and fix your vulnerable code. If you are familiar with the concepts of static analysis and code scanning, you may understand the terms sources and sinks. So where is my data coming from? Where is my user supply data coming from? And where is it flowing to? What sinks is it flowing into? And so as you start to approach your code and review your code, all of those tags and all of those functions from the past two slides should be considered as dangerous sinks. So potentially dangerous functions that if they consume user data, user supplied input, they could lead to a vulnerability in your code. And so we're going to talk about some options and some strategies to find those functions and go through them. You're also going to want to validate user input, and we're going to have to understand what user input is, and we'll talk about that shortly too. Again, there's no kind of catch-all in terms of the best way to validate the user input here. It unfortunately may depend on application functionality specifics, so it's not as easy as when you want to fix SQL injection in ColdFusion, you're right off the bat going to want to use something like CF query param. Server-side request forgery, it may depend a little bit on what the application needs to do, what kind of data it's expected to process. So there unfortunately may not be an easy catch-all or an easy fix right off the bat. There's also a couple of things that you can do on your ColdFusion servers or your Lucy servers to make it harder for an attacker to actually exploit these vulnerabilities or do bad things with them. And so even beyond the kind of ColdFusion things that you can do, even beyond fixing your code and tuning your servers, if you're able to tightly control your environment, you could use stricter network configuration, stricter outbound egress filtering, so that let's say your server doesn't need to talk to most of the internet. If you're able to filter what servers, what hosts it can go out to, the attacker won't be able to connect to them. The same thing goes for your internal host too. If your web server doesn't need to talk to a lot of your internal environment, and you are able to establish that strict outbound network filtering, you can prevent some of these attacks that way too. Okay, so user input. In ColdFusion, there are a bunch of sources of user input. So certainly all the variables in the URL scope. So if you're passing URL parameters, those are all things that the user can directly control. Same thing with the form scope. So content uploaded through a form, cookies. So things like cookie names, cookie values, all get stored in the cookie scope. Again, can all be directly controlled and modified by the user. CGI scope is something that can be partially controlled by the user. There's some CGI variables that the user can control, but there's some that are going to be hard set by the server or by the application that the user can't control. So this is only some, but it's important to understand which ones the user can control. And that in some cases is going to require more testing. And then finally, the hardest category to pin down is that you also want to make sure you have coverage for tainted variables. So if you are deriving secondary variables from any of those other sources, so from URL parameters or form data or cookies or anything else, those could be also ways that the user is able to control the data. So let's say you take in some data from a URL parameter and then immediately use that to create another variable. Well, that's something that's tainted and something that a user may be able to control. Same thing goes with if you take that data in pass it to a function, and then store the result or the return value of that function. Depending on how all the pieces are working, the user may be able to do something unsafe. And then finally, if you're taking in one of these user-controlled variable sources, storing them into a database, and then later, let's say, retrieving that database value, that's again one more source of user-controlled data. So certainly, kind of finding and identifying all of your tainted variables is going to be the hardest and trickiest part here. But really, the bottom line is that if you pass any of those user-controlled inputs into any of the affected tags and functions here, you could be vulnerable, and there's certainly areas that you're going to want to review further. Okay, so what are some of the ways that we can go about actually finding those tags and functions? Well, if you're running code scanning tools or static analysis tools, those tools may flag some of these functions. You're going to want to make sure that you have coverage for all of them. So that's certainly something to test. From a kind of quick and dirty way, you can just even start with raw code searching. So use your code searching ability, even if you just use something like grep or file or text searching to look for those tags and look for those functions and kind of dig in a little bit deeper. How to do this could probably even be a longer talk and something that could get even more involved. But just to show two quick examples using PCRE grep. So this is a grep variation that's available for both Windows and Linux Unix as an add-on. This is one way that you could run some quick and dirty searching. Again, the searches here, the regexes here aren't perfect. They are going to lead to some false positives, but at least for me, I would rather start with a bigger set of possibilities and not miss anything versus kind of tighten these down and miss some possible vulnerabilities. Again, the reason why I'm using PCRE grep is that you can do multi-line searching. So you can match these patterns across multiple lines. So if your tags or if your functions span multiple lines, you're able to match against those. Again, I also will acknowledge that there's lots of ColdFusion formats. So depending on your ColdFusion style, this may or may not be particularly effective, but it's at least something to maybe think about and something to try. In terms of running these things, what you need to change is the stuff in blue. So for dangerous func, you want to give it the actual function name that you care about. And for the dangerous tags, same there, as well as specifying the path to your code. But again, these are at least a quick smell test to see, well, am I using these functions? And are there things in my code or my application that I may need to dig into further? Okay. I passed this behavior and these potential vulnerabilities onto Adobe PSERT just to see if this was a case of, yeah, this is dangerous, known functionality where developers just need to be careful, or whether or not there were things that they may consider a product vulnerability that may need to be addressed. Paraphrasing here from PSERT, the full PSERT response is on the blog post that I mentioned earlier, and I'll link to it at the end too. PSERT's response was that these tags and functions use Apache Commons VFS, so virtual file system. And so there is an XML file inside of a jar file that you can go in and edit to enable and disable various URI schemes. So for example, you could turn off support in VFS for all FTP URLs or all file URLs or all HTTP URLs. They also did acknowledge that they may release a future version of ColdFusion that contains an easier way to do this. I have not fully tested the PSERT recommendations, so I can't say for sure that it'll work. My hunch is that There may be tags or functions that don't use VFS that still could be vulnerable, but again, can't say for certain. Also, ColdFusion Sandbox may be able to provide some control around this. Again, I'm not a ColdFusion expert, I'm not a ColdFusion server expert, so I've looked at Sandbox a little bit. I've not fully tested it. I'm not sure. It looked like you'd be able to control some of the tags and functions, but maybe not all of them. But again, if you're familiar with Sandbox and it's something that you're using, that may be one place where you can do some more configuration and lock this down. Okay, for Lucy, again, similar to ColdFusion, Lucy has resource providers that these functions are going to consume that are on a virtual file system as well. So again, it's known and expected that you can pass in things like file URIs, HTTP URIs, and those other VFS schemes. Those can be enabled and disabled in lucyserver.xml. But again, like ColdFusion, it's going to be kind of an all or nothing. So if you disable one of those schemes, none of your functions are going to be able to use that virtual file system scheme. Let's see. And so, like I said about ColdFusion, Lucy, I actually did test a little bit more. And again, this will only apply to the tags and functions that do use the resources abstraction. Some tags, so things like CF HTTP, don't use the resources abstraction, but CF HTTP is one of those cases where for a long time it has been known and documented as a potentially vulnerable function. So this may have kind of more security attention than some of those functions that may have been off folks' radar in terms of being able to use for server-side request forgery. Okay, so as we start to wrap up and wind down a little bit, you have a list of vulnerable tags and vulnerable functions. You're going to want to review your code for those and look to see, do you have possible instances of server-side request forgery? Across the board, you always want to validate user input. That's kind of secure coding 101, whether you're worried about SSRF or any other type of vulnerability. When you have the results of that searching and results of that testing, you're going to want to find and fix all the occurrences that you find, secure your environments either through code changes, network changes, server changes, to make it so that attackers can't exploit them. You also may want to think about ways to maybe build some guardrails or avoid it in your new code. So whether that's through developer training, whether that's through code reviews, peer reviews, but once you fix all your existing cases, if you have any, you're certainly going to want to make sure that no new server-side request vulnerabilities creep into your environments too. And again, I'll say one more time that this is just one small piece of everything that you need to do to build secure ColdFusion applications. There's lots of great resources online, past CF meetups and other sources that cover a lot of those topics in great detail. So certainly server-side request forgery is important, but there's definitely going to be a lot more that you're going to need to do to make sure that your applications are safe and can't be exploited by attackers. Okay, here's my contact information. Happy to answer questions, feedback, anything else after here. My email, Twitter, and the blog are both fairly low volume, but certainly if I do anything else regarding ColdFusion in the future, they will be linked from there. And again, you can find the blog post where I talk about the functions and tags that are vulnerable directly off the blog or off of the short URL, tiny URL SSRF in CFML. Okay. That's what I had. Thank you very much. And I am happy to open it up to questions if we have any.
Awesome. Thank you for that. There haven't been any asked so far. I've shared some comments.
Awesome. I see that the blog post is in there. Perfect.
Yep.
Thank you.
Yep. And while we're waiting, well, awesome. You go ahead. And, yeah, go ahead and read.
I see that the blog post is in there. Perfect.
Yeah.
Thank you.
And while we're waiting, well, you go ahead. Yeah, go ahead and read.
I see that the blog post is in there.
And once you've caught up, I'll share some thoughts.
Yep.
Okay. So I just wanted to share, you may have noticed there I talked about the sandbox like you asked about. So yep, the sandbox can help with this problem. It's not something a lot of people use. I've been actually thinking about doing a meetup on it because it's not new. It's been around forever. I wrote a post on an Adobe, gosh, what they used to call the developer connection, you know, like 20 years ago, and it's not really changed too much. Some people try to run it and have trouble. And there have been different solutions over the years. So anyway, I could put together a post on or a talk on all that. But yeah, it would definitely be able to help with this in that you can limit what domains or IP addresses can be called from CFML code, and you can limit that to a particular application and its code or to the entire instance and all CFML code. And I was doing some checking, so you may have covered this, but I didn't think I heard it. I can confirm I put together that FileGetMimeType demo that you offered, and I can confirm that the CF security analyzer didn't find it, didn't flag it, and I'm trying Fixinator while we're talking, and it's not flagging it. And for those who don't know, the CF security analyzer is Adobe's security analyzing tool. It was introduced in CF 2016, and in 2016 and 2018, you had to be using Enterprise to use it, which I thought was terrible. And then in 2021, they've lifted that requirement, and you can now use it with Standard or the Developer Edition. So anyway, the CF Security Analyzer, which does require Builder, even if you don't want to use it, you can use it just for scanning security. But I'm just saying I confirmed that it doesn't catch it. And then similarly, I can say that the Fixinator didn't catch it, and that's something we could bring up to Pete, and he's pretty good about addressing it. You know, he'd at least add a warning to say, beware what you're doing could be subject to server-side request forgery.
Okay, yeah, sounds good. Yeah, when I looked at CF Sandbox, and again, I'm not super familiar with it, so it may have been user error. It looked like I could enable and disable certain tags, but I wasn't able to.
Yeah, forget about the tag stuff. That's a separate subject. I mean, there's a lot you can do in the sandbox.
Okay.
And we're not talking about controlling what tags you can do. We're just talking about what can those tags do. What can any tag do?
And then I wasn't sure if CF Sandbox would control things like virtual file system requests, or if those network controls were just for, let's say, if you did have a CF HTTP or CF FTP,
right?
So like all of your raw network socket stuff,
right? That's an interesting question. I don't know if I can.
Okay, yeah, no. So like I tried to set it up. I wasn't confident in my ability.
Sure. So and if you want to get together sometime and try it, I'd be happy to help you for the sake of science and the community. I'd be happy to help you get that set up. So cool. And yeah, no more comments. There's a couple dozen people that are watching. They're all very quiet.
Possibly scanning their code.
Right. Running off. Oh my gosh. And let's clarify that the posts you did were back in April on the first post on this. In fact, it was your very first post of your blog, right?
That's correct.
And then your second post was an introduction. But yeah, so this isn't really new information. It's just that, you know, you may not have heard it, folks. And thanks very much for what you've done to call it out, make people aware of it. And let's hope the word spreads.
Sounds good. Yeah, happy to spread awareness, and hopefully this will lead to more secure applications.
Absolutely. Absolutely. And so are there any remaining questions or comments that would take us in a perhaps related but different direction than what's been discussed so far? One thing I will say, I hadn't seen the blog post back in April. I just discovered it all when we started talking about arranging this to be a meetup. And I'm realizing when I saw your presentation, you had that table of the tags and functions and the indications with the asterisk that said Lucy. And I would just suggest that you might, if you have a few minutes at some point, think about modifying at least that blog post as people find it to clarify that you're not meaning those things are only in Lucy, but you're saying your observation of vulnerability was only in Lucy. Like you had CF dump,
yeah.
right? Of course, everybody would know CF dump, of course, is in ColdFusion, but your point was CF dump is vulnerable to the SSRF in Lucy in a way it's not from your observation in CF. So I just think if you said, vulnerable in Lucy instead of just Lucy, some people could get confused and think, well, I don't have to worry about that one. I'm not on Lucy. No.
Sounds good. No, I appreciate that feedback, and that makes sense.
And thanks, Astor Grove. Yep. So we'll do that perhaps very soon, because it's a topic that I've wanted to do. And Albertus, these security talks will often get your brain spinning. And I made a comment back at the beginning that you don't want to dismiss this and think your code doesn't do it. It's not about your code necessarily. It's somebody else's code. And you actually came along shortly after that and said the same point. It could be an open source project you got or a product you got. So you got to be careful. And so really you need these mitigation capabilities. And another thing that I've wondered about, and maybe somebody might want to take this ball and run with it, is getting some listing of what domains or IP addresses got called during the life of an instance. In our case of ColdFusion or in Lucy or in any Java application server. And somebody might say, oh, that's easy. Well, if it's easy, write a blog post and share the word, because I was looking for it and didn't readily find it.
Good point.
Because then you could at least audit it and you go, hey, what's that? I should back up and say somebody might want to point out that tools like Fusion Reactor and the CF PMT do both have the ability to look at what outbound calls have made from CFML. So you can see CF HTTP calls, CF, FTP calls, CF, other exchange calls, things that called out. There's ways with both those tools to observe outbound calls. And in the case of the PMT and Fusion Reactor, they tend to just focus on like the slow ones. And as far as what they keep historically, they would tend to keep just the slow ones. Fusion Reactor does keep the most recent 100, but again, both of those don't really help with looking at things after the fact. And actually, somebody might point out that the CF HTTP specifically, and a few other tags like it, have logs, and this might be of interest for you to be aware of, Brian. There is a CF HTTP log. It might be called the HTTP log. I can't remember. But that's not a log. That's not an access log. That's a log of what calls were made out of CF to, via CF HTTP to something else. And it logs when it starts, and it logs when it ends, and logs how long it took. And so someone could parse that log with a tool to pull out what were all the domain names that were called. But I meant it'd be nice if there was some easier way, especially one that might be more generic to all Java app servers, not just CF and Lucy. Well, it doesn't look like there's any more questions or comments. Brian, any thoughts that have come up while you've been either looking or thinking?
Nope, that's about it. But thanks again, Charlie. This has been great.
Awesome. Well, thank you very much for coming on. We look forward. If you have more discoveries, we'd love to have you come on. And if you want to talk about any other topic related to security, there's no reason to have only a couple topics on security. Pete Freitag in particular is especially well known for it. Others in the past have done it, and some of them has been a while. So if there's any other topic that you think, bringing it to people's attention would be worthy, I'd absolutely welcome it. Or anybody else listening, if there's any topic at all related in any way to CF, CFML, even Lucy, if you'd like to have it presented on the meetup, just let me know and look forward to it. All right,
Sounds
Brian.
good. I appreciate the offer.
You betcha, man. Well, thanks very much. And everybody, we'll talk to you guys when the next one happens. Until then. Oh, and let me just say before I hit the button to end, all the meetings are recorded. This one will be available as soon as I hit end. It'll be available on YouTube. What won't be available immediately is the chat. For some reason, YouTube takes time to process that, but you'll be able to see the recording of the presentation immediately as soon as I hit end. Okay, here we go.
Okay.
Yeah.